pineapple represents a scientific data set. I want to ingest this data set, but I can't exactly just take a bite out of it. It's too big and it's got a hard skin around it. But thankfully, I know about a tool I can use. Programming. Programming is a very helpful tool that can help me peel this pineapple and cut it into smaller pieces. You have a data set that you want to visualize using visual effects software. The software knows how to read file formats like spreadsheets or OBJs, but it doesn't know how to interpret your data format. If you come across a problem that you can't solve using the built-in functionality of off-the-shelf software, you can usually solve it by writing your own code. Programming can be relatively simple or very complicated, and I'm not going to get into the specifics of how to do it, but I will get you started with some information. One of the simpler types of programming is called scripting. It's a type of programming that's meant to be fast, easy, and good for automating tasks. Or traditional programming with popular languages like C++ or Java is what's usually used for large software efforts, creating big tools like Microsoft Word, Facebook, the Android operating system. Scripts are often used for smaller, specific tasks and may or may not be reusable. Scripts can be as short as one line of code, and they're usually contained to a single file. They're often written in a simplified programming language that's more specific to the purpose as well. Certain software tools let you write scripts directly inside their interface. Here I have a box. If I want to change the scale in the X direction, rather than specifying it directly, I can write a code snippet that takes the size in Y and doubles it. Then, when I update the size in Y, the size in X is also automatically updated. This kind of script can make my design workflow much more efficient. I can also write a longer script in a separate scripting window for a more involved process, like repeating a step multiple times, more times than I'd like to do manually. This program is importing camera positions. As each position is read, a tick mark is added along the time bar at the bottom of the screen. This particular code is written in the scripting language Python. Different languages are supported by different software, and some tools have their own custom scripting languages. Some tools, notably Houdini, Nuke, and Unreal, have a visual node-based scripting interface where you don't actually have to write code. The idea is that each node represents a piece of code, and you can wire them together in whatever way you want. Here we start with a regular plane, and we apply a custom node that represents a script to it that changes its appearance. Let's see what this node is built out of. So here we have a network that represents our script. Each one of these nodes is actually a script of its own, just a smaller one that we've wired together to create this bigger script. This node at the beginning of the network represents the input, the regular gray plane, and this node at the end represents the output, this colorful wavy plane. There are actually two processes being applied to this plane, represented by this top path and this bottom path. If you'll notice, the colors on this grid actually go around from red to blue. That's because this node is a script that's converting the coordinates to polar coordinates, and this one is applying the colors to it, from red to blue. This bottom path is applying random noise and adding it to the position, making it appear wavy. This network is actually building a script, just like the ones we've seen before. And we can actually take a look at what that looks like. Using a node-based visual scripting language is a faster way to do programming without having to memorize syntax or debug programming grammar. But let's get back to our problem. What if we're working with a data format that our software can't understand? Scripting is one of the possible ways to get around this. You may want to write a script that translates your original data file in its scientific format into a new data file that visual effects software understands, and then simply import that new file. This is called data pre-processing, because it's something you want to change about the data before you can begin working on your visualization. Data pre-processing is typically done outside of the visualization software you're using, in an external script. If you had a script that could cut a pineapple, that would be an example of an external pre-processing script, since this is something you do to your pineapple data before you import it into your mouth and start ingesting it. You may want to pre-process your data to change the file format, or to do optimization like thresholding, or to apply some mathematical operation to your data. Preprocessing your data can save time down the road, so that you don't have to wait for the data to process every time you open your scene file or render an image. This visualization of a hurricane was 5 terabytes, which was particularly impressive when we were working on it in 2011. But there was a lot of data that we didn't need for this visualization, so we applied optimizations in the preprocessing step to bring it down to 1 terabyte. If you need to process your data, you don't necessarily need to preprocess it. You can choose to process your data internally to the software, on the fly, at the time of visualization. This may impact your design process, and can be beneficial if you want to keep reprocessing your data in different ways. I can take a bite out of this pineapple whole and spit out the parts that aren't edible as I chew. This will make the eating process a lot slower, but it means that I can quickly decide whether or not I like the flavor, and I can choose to process each bite of the pineapple differently. But what if I could eat the pineapple without having to process it first? If I could open my mouth as wide as a hippopotamus, I could swallow the pineapple whole. Obviously, I can't actually do that. But a lot of software does let you make changes to it to extend its functionality. Rather than changing your data so that the software can understand it, you can add code to the software to make the software understand the data. A plugin, sometimes called an extension, adds a new feature to existing software, and is typically written in a programming language like C++. Most major software packages have what are called development kits that have reference manuals and example code to help you get started with creating your own plugins. Plugins often update the user interface of the software, but they look seamless, as if the feature was part of the original software. For example, you could add a custom data reader node into the interface menu. This node looks like part of the native software, but it's actually a program I wrote that reads many different scientific data formats. Or you can write a plugin that adds a new native geometry shape to the software. So in addition to common shapes like a sphere or a cube, you could also give it access to a bunny shape. You might find that the other shapes are too uniform, and this bunny shape is much better for tests that require geometric irregularity. You can write a plugin to add just about any new feature directly into the software interface. This extension makes it so the Houdini nodes spin around continuously. And this plugin converts the nodes into a game of Snake. You can get very creative with programming. You may be able to find plugins and scripts that other people have already written and use those rather than creating your own from scratch. There are several websites listed on the course resources page where you can go download plugins for a wide variety of tasks. If you want to write your own code, we also list places where you can get programming advice and look at other people's code examples. Many programmers freely share their working open source code, which is code that you can modify and use for your own purposes with proper licensing and attribution. Or you can contribute to these open source coding efforts to help out with larger scale projects. You don't have to consider yourself a programmer to write snippets of code or to find code online and modify it for your own purposes. The most basic programming skills can get you quite far and will make your life a lot easier. Fun fact: there are over 700 programming languages, and more are being developed every year. This count doesn't even include esoteric programming languages, which are often created as a joke and are intentionally difficult to use. Some examples of these languages include lolcode, which is designed to resemble the speech of lolcats; whitespace, which only uses spaces, tabs, and returns; Shakespeare, which is designed to make programs look like Shakespearean plays; Pete, whose programs are bitmap images that look like abstract art; and many, many others.